Consider a triangle, not necessarily right-angled. Let's call the lengths of the sides of this triangle A, B and C, and we'll also call the angles of this triangle A, B and C, using capital letters to distinguish them from the lengths, and arrange so that angle A is opposite the side of length A, angle B is opposite the side of length B, angle C opposite the side of length C. For convenience, let's reorient this triangle so that one of the sides is horizontal from our point of view. And we'll drop down a perpendicular line from the peak of this triangle to its base. This divides the triangle into two right-angled triangles, and we'll call the length of that perpendicular line that we've dropped down h for height. We can now do some calculations. In the left-hand triangle, by definition, the sine of the angle A is equal to the length of the side opposite, which is h, divided by the length of the hypotenuse of that triangle, which is b. In the right-hand triangle, the sine of the angle B is equal to the length of the side opposite, which is also h, divided by the length of the hypotenuse of that triangle, which is a. Rearranging both of these, we can have that h is equal to b times the sine of a, or that h is equal to a times the sine of b. So putting these expressions equal to each other, we have that b times the sine of a is equal to a times the sine of b. Dividing both sides of this by the sine of a, we have that little b is little a sine big B divided by the sine of big A. And finally, dividing through by the sine of b, we have that little b over sine b is equal to little a over sine a. But there was really nothing special in the way we did this, in the fact that we chose to use the angles A and B. We could have done this in a different way using, for example, A and C, or B and C. This would lead us to the following general result. If we look at A divided by sine A, or B divided by sine B, or C divided by sine C, we would always get the same answer. This is called the sine rule. It's best summed up in this single expression with two equalities, but it's important to remember that it's really telling you about three different equations. It's telling us that A over sine A is B over sine B, also that B over sine B is C over sine C, and that A over sine A is C over sine C. Rather than thinking in terms of A's, B's and C's, it's easier to think that in a given triangle, if you take the length of any side and divide by the sine of the angle opposite, you will always get the same answer. Here's an example of the kind of question that we can solve using the sine rule. Find the length of the side labelled x in the triangle below. So using the sine rule, we can say that the side of length x divided by the sine of the angle opposite that side, which is 50.6 degrees, will be equal to the side of length 7.5 divided by the sine of the angle opposite that side, which is 34.9 degrees. So, multiplying through by the sine of 50.6, we have that the length of the side x is 7.5 times the sine of 50.6 degrees divided by the sine of 34.9 degrees, and using a calculator, that gives us a value for x of 10.1 to 3 significant figures. In this question, we're asked to find the length of a missing angle in a triangle. Once again, we can use the sine rule, but if we're going to find an angle, it's better to start off with a slightly different form. So here is the form of the sine rule we've been using so far. If we take the reciprocal of every fraction here, we'll end up with a slightly different form, where we have the sines of the angles on the numerators and the lengths of the sides on the denominators. Again, remember that this is a summary of three different equations which we should select according to the problem that we have. So in this question, we can write the sine rule as the sine of the angle x divided by the length of the side opposite, which is 3.6, is equal to the sine of the angle 61.2 degrees divided by the length of the side opposite, which is 6.6. Multiplying through by 3.6, we have that the sine of the angle x is 3.6 times the sine of 61.2 degrees divided by 6.6, and therefore the angle x itself is the inverse sine of this fraction, the inverse sine of 3.6 times the sine of 61.2 degrees divided by 6.6, which using a calculator is 28.6 degrees to 3 significant figures.